Hello. In today's session, we will be covering a few more topics of networking. Let's start the today's session. The first topic is NIC, that is Network Interface Card. The function of Network Interface Card is to associate a gadget to a network. That means every gadget which are associated with a network is having a network interface card. Yes, even the routers and switches have network interface card, that is NICs. In the picture, you can see that how NICs looks like. It provides communication between computers on local area network by converting the data into a format that is suitable for the networking medium, which means that is electrical signals for Ethernet, um, radio waves for Wi-Fi, and etc. Each NICs that has a unique media access control address, that is MAC address, versus a physical address that occurs at data link air. MAC address is unique for every device which is associated with a network. Because of this reason, data which has been transmitted can reach to a destination using the MAC address of a device. MAC address is a 48-bit um, unique hardware number of a computer or of a device or gadget, which is associated with any kind of network. A MAC address is a 12-digit hexadecimal number, or we can say 6 bytes number of 6 bytes. It is represented in the form of hexadecimal notation, that is colon hexadecimal notation. Out of 6 bytes, uh, the first 3 bytes are reserved for OUI number. What is OUI number? OUI, that is Organizational Unique Identifier, is a number which is being provided by the organization which has manufactured the NIC cards. IEEE organization, IEEE assigned this OUI number to the organization. The OUI number of an organization are fixed, and the second and the another 3 bytes it is reserved for the device. It is unique in every device. Okay, we can identify the manufacturer of NIC card with the help of MAC addresses, as the OUI number is given. It's not fixed. A manufacturer have only one OUI number. It can have more than one OUI number as per the requirements. The rightmost 3 bytes or 6 digit represent are assigned by the NIC card manufacturer, which is unique to a device. That is, no another device have that number. This configuration makes a device unique itself, so that any data which has been transmitted to this MAC address, um, it would reach to the destination easily. Here are the types of MAC addresses. The first one is unicast. A unicast addressed frame is only sent to the interface leading to a specific NICs. In this picture, you can see that a host is sending a message to the server. Such is called unicast. That is, the source is sending the message to a single or a specific device, Okay. For unicast, as we know, host provides uh, message in the form of frames. Okay. In a frame, destination MAC address, source MAC address, destination IP, source IP, everything is mentioned, isn't it? Now, for unicast, when a host transmits a message or a frame, in that frame, the, the, in destination MAC address, the rightmost um, uh, the uh, the LSB or loads the LSB bit of rightmost byte represents the whether uh, the message is for unicast or multicast. Okay, if if the LSB of the first byte of destination MAC address is is one, then the zero. If the hub, switch, or bridge get such type of destination MAC address, it forward this message to all the connected members or all the connected devices. Sorry, it forward the message to the specific device which is having this maximum this a specific MAC address. Okay. Now coming to the multicast. In multicast, the message or a frame is forwarded is transmitted to a group of devices. In for multicast, when a host transmits a frame, the the LSB of the first byte of the destination MAC address is 1. Next one is broadcast. Broadcast is forwarding a data to all the connected devices. Where the middle or the bridge switch if get a mic an IP address make sorry if a bridge get a destination MAC address of uh, broadcast format, it transmit the message or frame to all to all another other connected devices. Ethernet frames with 1 in all the bits are referred as broadcast address. In hexadecimal form, it is all F, represented by all F. Like we'll be knowing about how we can know MAC address of our device. Okay, first of all, open the command prompt and type ipconfig /out. A window will open. In that window, we can find the IP address and the MAC address. Okay, the MAC address is in the form of physical address, which you can see on the screen right now. This way, you can know your MAC address of the device. The topic is Ethernet. It is a technology which is widely used in local area networks. It provides communication between devices such as computers, printers, and servers within a small geographical area. Why it is a small area, we will be discussing about it in further slides. It is used in our homes, offices, and small organizations. Okay. Ethernet connections can be established in many ways, depending on their type of cabling and network configuration. In direct wired connection, matlab, means uh, in wired Ethernet connections, there are three main cables which are playing a crucial role. That is, the first one is twisted pair Ethernet cable, fiber optics Ethernet cable, and coaxial optic Ethernet cable. We already have discussed about these three cables in previous sessions. Now there is another Ethernet connection. Another kind of Ethernet connection is which is wireless. That is Wi-Fi. It's not actually Ethernet, but it provides a wireless alternative to wired Ethernet connection. To connect all the devices present in a local area network wirelessly. Wi-Fi uses radio waves to transmit data. Okay, here is the few limitations of Ethernet. The first one is distance limitations. The maximum length of a twisted pair cable is 100 meter, or we can say it is around 100 meter. And sometimes it can travel, with latest technology. It can be 200 kilometer, 300 kilometer, but it's not more than that. This is because data or frames travel in the copper cables in the form of electrical impulses or voltage. That is, for zeros it is 0 volt, and for 1 it is 5 volt. It is assumed, but as the cable get elongated or more than a range of 100 or 200 kilometer, the sharpness of the varying voltage uh, reduces, which results in reduced performance and possible data loss. Now, this it was for copper cables. For fiber optic cables, the distance is limited because it is of very high cost. The cost of establishment is high. Similarly, few more limitations of using Ethernet is latency, portability, and many more things. Okay, the main limitation is the distance. Okay, even in Wi-Fi, we have very low distance of coverage. If we increase it, we may have to pay much more. It is broadcast and collision domain. A broadcast domain, a broadcast domain is a logical area in the network where all broadcast packets sent by a device is received by all other devices in the same domain. That is, if the second one is collision domain. Okay, a collision domain is a network segment where data packets can collide with each other when being shared in a medium between two devices or two computers. Let's assume a scenario where uh, two computers are sending data with uh, channel or with on internet Ethernet. Both shares data at the same time. When or both transmit data frames at the same time, it will be on a single Ethernet, which is half duplex. When they come in contact with each other, they will collide with each other and disturb the data. Okay, the data get bursted. Uh, so the computer have to, so the host have to um, listen the frame, okay, or data. This is collision domain. Here we will be knowing about CSMACD, that is Carrier Sense Multiple Access Collision Domain. Okay, it is a network protocol used in Ethernet networks to manage data transmission, where devices detect carrier signals to avoid collisions. Let's understand the collision and what CSMACD wants to say. Let these two computers are A and B. Okay, they transmit data. If both the computer transmit data at the same time, definitely it will collide. Okay, actually it's do a sense carrier sense that um, if A have to send a data to B, it check whether the channel is empty or not. Okay, or is suitable for transmitting data or not. It, for example, first for it check and transmit the data. For example, it transmitted data. Still there is a problem. It transmitted data, but after some time, it also transmitted data. Okay, definitely there would be collision. I don't know what. Let the propagation time of data from both the computer A and B is 1 hour. Okay, let's assume since as we know it's not 1 hour, it's very few, that is a millisecond. Okay, let's assume a scenario when host A transmitted a data and it get collided at here, and it will receive the collision signal after 1 hour. No, you have to transmitted data. It took 1 hour to reach here and get collided, and this collision signal will be received by A after 2 hours. That is, if host A transmitted data at 12 o'clock, it will receive the data. It will receive the collision response at 2 o'clock. What is? It would not sense the collision if the host A is still transmitting messages or data or frames. Okay, so to detect the collision, the host A should be transmitting frames at, or should be transmitting um, till the collision signal reach to A. Okay, that's why there is a formula introduced is transmission time should be greater than or equal to 2 into propagation time. That is, in this case, the transmission time should be uh, 2 hours. Okay, then only the host A would be detecting the any collision occur in the channel or Ethernet. An Ethernet frame can be said as the basic unit of data that is being transferred in a Ethernet network. Okay, that is, data is transferred through Ethernet in the form of frames. Okay, here, here in this slide we will be discussing about Ethernet frame. Okay, here you can see uh, uh, here you can see the in first segment of the frame it is preamble, which is represented here is as PRE, preamble. Okay, it is of 7 plus 1 byte. Okay, it is assumed to be the starter of the frame. Okay, and okay, why I said preamble is of 7 plus 1 byte, that is because in preamble the 7 byte is uh, is 10 in the format of 10110. Okay, and in the 1 byte it is the format of again, but the LSB is 11, as you can see here. Okay, now the second segment is destination address. Okay, here destination MAC address. Okay, in this segment destination MAC address is put it. You can see here it is of 6 bytes. Okay, uh, and the next is source MAC address. You can okay, again it is of 6 byte means in this segment the MAC address of destination is fitted, and in this segment the destination of source the MAC address of source is fitted. Here in this segment, type, it represents the type of upper layer protocol contained in the data. Okay, now in the next segment it is data, or it is the data. Okay, here and you can see the padding of it is because in different OSI layers, in different OSI layers, data there is header and tail attached in the data. This entire I put it in this segment, uh, that is data or padding. It is not of any fixed bytes. Okay, uh, it can be varying from 46 bytes to 1500 bytes. Yes, the data should be uh, a minimum of 46 bytes for to be in a one frame. Okay. Okay. Um, Here it was the data which is being actual data which was being transmitted. Now the last segment, it is FCS, that is frame check sequence. Okay, it is checksum used for error checking in the frame. Okay, basically it does some calculations on the basis of the following structure, and which is being which uh, is decoded at the destination level. Okay, and thus it is calculated whether the data is safe or not, exactly same or not. It was the structure explanation of Ethernet. Um, okay, version 2. Okay, now the structure in the below is of Ethernet IEEE 802.3. Okay, here the difference is the length. Okay, here it is the length of the frame instead of um, instead of type. Okay, this is the basic difference between both the types of Ethernet. Okay, paired cables come in three varieties. The first one is a straight throw cable. Okay, in this cabling, um, the cabling is done end to end, as you can see in this figure. Okay, in the same sequence, cabling has been done in same sequence as uh, okay, and here it is reverse, or it is now it is crossover cabling. Okay, um, and this is done in crossover. Oh, and it is here it is rolled cabling. Here it is the mirror image of connections. Okay, now what is the purpose? Let us discuss that. Okay, a straight throw cable is used to connect the devices of uh, which are present or which are used in different layer of OSI model. Okay, it is for uh, devices which are in different layer of OSI model layers. Okay, where the crossover cabling is which are for devices which are at the same layer of OSI model, and the rolled cable is used to connect the console port of the router switch. Okay, clear? The switch evolution of switching. Why it is needed? Why switches, hubs, presses is needed if we can do connections like in this way? Okay, let's know about it. As we know, Ethernets, wide Ethernets have limitations that it cannot be more than 100 or 200 meters. Okay, so it can be, but it cannot transmit the data as it is after the 200 meters, 100, 200 meters. Okay, for that reason, hubs and repeaters are introduced in the connection. Okay, each actually do. Um, Here you can see after 100 meter, yeah, there is a hub or repeater. Okay, it do as amplifier. It works as an amplifier. It reboosts the electrical signal and forward again uh, to 100 meters. Okay, and again there is hub and repeater, it can again forward 100 meters, and it can goes with and so on. Okay, that is for after every 100 meter, if we put a hub or repeater, then we can do a long connections as much as I want. Connect two devices or more than two devices far which are far away with each other with the help of these devices, these hubs and repeaters. Okay, with Ethernet, which was previously not possible. But there is a problem in it. As the number of devices will increase, the probability of collision between the frames will also increase, isn't it? And as the collision probability of collision will increase, the transmitting of data or communication of data will be more difficult for the devices. So, another device has been introduced, that is bridge. It has a memory element present inside the bridge. Okay, if a data is being transmitted by, let's assume, host A, and if any collision, first of all, and at the same time another data is being transmitted with host B, there should be a collision. Okay, isn't it? But what bridges do, it stores the data of A here in its memory element, and the uh, the, uh, let the frame of B, data frame of B, goes to the A, and as the transmission occurs, as B reach to the destination, bridges send the A to the B. Very good. What happened here? The data which were sent by A and B at both the at same time in same direct in same channel or Ethernet cable, which were to transmit with each other, which were to collide with each other, but due to bridge and its memory element present in the bridge, it it didn't occur, and the data reached to their destination. Okay, which was not possible in hub due to the lack of this memory element. Okay, there is a demerit of this too. See here, every host is transmitting data in 10 Mbps. Okay, 10 Mbps. But uh, let's assume the server which are connected to bridge have to transmit or receive data in 100 Mbps. Okay, it can't be possible in bridges because uh, in bridges all the ports accept only same speed of data. Okay, it can be of 100 Mbps too, but if the bridge is of 10 Mbps, then it would not accept the 100 Mbps as Ethernet cable. Okay, and here the another device comes into the role, that is switch. In this device, all the ports can be a variable Ethernet connection. That is, if a host is transferring 10 Mbps, another is transmitting 100 Mbps, there is no problem with it. Okay, it can transmit. And even in switches, there are more ports than there are many ports more than bridges. Okay, it's just these all three devices which were hub and then bridges and then switches are the extensions of each other. Okay, in such devices, if any collision occurs, there is still a probability of collision. It's not okay, there is not collision, but if any collision occurs, suppose in this network, it would not affect remaining network. Okay, the remaining network would be as it is. Okay. It was all about evolution of switching, how switching came into the play. Okay,